What is up, amigos? Today we're talking about sunroof vortex generators, and do they have them? It's a question. The reason why is because if you look at this picture, for example, this is of an old Volkswagen, and you can see that the sunroof, where it starts, is actually quite crisp. It's just one straight line. Contrasting to this picture, which is significantly later, so it's a newer car, the front of the sunroof, you can see, is a little bit jagged if you look very closely. And if you actually were to look from front on, so let's say we have the car in front of us and we're looking front on, and we look right at this point, we'll see that it looks something like this. Often they do change a little bit, but generally speaking, they do look like this. So that's the edge, and this actually pops up when we're driving along, and when we open the sunroof and we're driving along. So are these things vortex generators? Are we going to be getting vortices off of these things? And if so, for what purpose? Well, the reason is it's actually not a vortex generator as they might seem. We actually have these on sunroofs for a good reason though. So let's say we're looking down on top of the vehicle and we have the sunroof open like this. And this is the front of the vehicle, so the flow's coming in this way. And we have this line on this front line here. So if we weren't having this here, what usually happens is the flow comes along, separates on this line, and typically there's a lot of turbulence, but there's a lot of turbulence often at one particular frequency or like a small range of frequencies. And this is not so good because if you know about sound, you know that if you have turbulence at one frequency, that will usually result in a tonal noise. So you have this like pitch at a very specific frequency. Things get worse when you look at the cabin itself. So you have air inside, and if you get to a certain frequency, the frequency of the shedding actually resonates with the air inside. This then amplifies the noise. So to get rid of this problem, we put in these little cutouts here, and we put them on the front here and they pop up into the flow. So the flow goes into the page like that, hits these, and now this flow no longer separates at one exact line, but at several different points. And this then breaks up the frequency into a greater range of frequencies. So the turbulence into a greater range of frequencies. So instead of having, let's say we have the frequency here in hertz, and we have the power here, so PSD, power spectral density. If we have a straight line and none of these serrations, we might get something that looks like this, that pops up and then goes down, and we might have some other features around. But if we have this serration, we will get something more along the lines of this, so it's much flatter and it's much more broadband noise as opposed to a tonal noise. That also results in the resonance of this air pocket inside the cabin not really being matched by the frequency being shed, because the frequency is now over a much greater range. And that is actually what these things are. They're not vortex generators as they may seem. So that is the end of this video. I thought it was really cool because I've seen these for a very long time and I've heard other people say like maybe they're vortex generators. So this was a cool idea to do, I think. So that is the end of this video. If you liked it, make sure to like it. If you didn't like this, click the subscribe button, and I'll see you in this video. Peace, amigos.